have a median and you have a mode, you don't have to use them all every time. The question is, which one should you use when? So let's talk about that, shall we? Here is a random sample of 100 American men and their LDL measurements. Okay, that's the results. LDL is low density lipids, aka bad cholesterol. So you want this to be as low as possible. I forget. I have to look it up. But there's a cutoff for, like, if you're above this, your cholesterol's too high. I forget what it is, doesn't matter. You want it to be as low as possible. If I had to ask you, based on this sample, what is the average LDL reading for these guys? Sample average. Which measure of center would you choose? And approximately what value does that measure of center have in this data? And just I want to preface this by saying there is not one correct answer. Any answer will do, so long as you can justify it. That's fair. That's what's great about this class. As long as you can back up your answer.
That's a mode.
Really? Here's some ideas. What do you think? Richie, go ahead.
I think mode just because it's visually looks like an easy.
I like that. So Richie says he goes with the mode. What would the mode value be in this case?
4.75 to 5.
Give me one. 5. I love it. You hear I call that 5? He called it 5 because that's right in the middle of that bar. Go ahead and do that. Totally fine. Good. So he's going to call it 5 because 5 is the highest bar, which means of the data points that we have in how we group them, 5 is the most frequently occurring. And that's what you're going to say, Lauren, right? Yeah. Your concern is that, that's because you group them like that. What if you group them differently? That's a concern with the mode. The mode, you saw that with your group data versus your raw data, right? The mode went from 2 to 4 because we grouped them in a certain way. So, but based on that, you can't choose. This is how it's grouped. I got no problem with that. Lauren, do you want to pick a different one to use instead of mode then? No, you can.
I was thinking about like how we do the median, how we chop things out on each side.
Want to do that? We'll do the median?
We could. This one's a little bit.
Well, let's do this. Let's street fight mathematics it. Those two are roughly equal to that, right? Yeah. Ends are gone. Gone. Those are about equal. Gone. Those are equal-ish. Yep. Gone. Median's going to be in there somewhere. Yeah. I mean, you see, that's fair. I mean, we can be more precise, but I guarantee you won't get a different answer than me. Yeah. Because why? Say that again? What's that curve? Well, it's a bell curve, right, exactly. If you think about 111, it's like a parabola-ish. Yeah. It's the same on one side as the other. So if you chop this half, it's going to perfectly balance this half. I like it. So what would your median be?
5.
5. So you got a mode of 5 and a median of 5. What would the average be?
That's hard to tell because...
Good. Good. It's hard to tell with exact precision. I agree, Rich. Here's another way of thinking about how to find averages, more, again, street fighting mathematics-wise. Imagine that as a plate of cookies on a tray, and you had to carry it using just one finger. Where would you put your finger in the optimum place to balance the tray? So I'm going to start over here, and you guys tell me where to stop. Okay? Bob Barker. Minus the gray hair. He's dead.
Stop.
Good.
There's no Bob's not dead.
Oh, somebody said not yet, so does that make you happier? Oh, okay. No, back here. Okay. But you see, everybody told me to stop somewhere in here, yeah? Now, I'm not going to get into a fist fight with you about how far left or right of that 5 we're going to be, because it's probably going to be pretty close to that 5, isn't it? And that's the idea. Think of an average as a balance point. Because if you don't have time or the ability to get the average, although you will in like a scientific journal, obviously. But if you're in the field and you've got to get a quick average, look at where you would put your finger to balance and go from there. Yeah. So, what would the average be?
5.
So, does it matter what we use? No. And here's a nice little guideline. And again, you're going to have this PowerPoint given to you on the schedule page. Write down as little as much as you have to because you're going to have the document. When your data is symmetric, which we already talked about, it doesn't have to be a bell curve. But as long as the left and the right sides are essentially the same shape, and as long as it only has one mode, it doesn't matter what you use. They're all the same, essentially. They're arguably the same thing. Generally, the average is used in this case. Generally, the average is used. But you can pick anything you want because they're all going to essentially balance themselves. Is that fair? Yeah. Good. And you guys just discovered that yourselves. It's perfect. It's perfect. Unimodal one mode. Yeah, so basically, you're not going to have a curve that does this, like humps twice, because you can have that. Very often, that's very fun when you have curves that bump twice, because then it indicates there's actually two different things going on. And it might be something as obvious as, oh, I grouped the guys and the girls together, and there should be two separate curves now, or something along those lines. Good? Does that make sense?
Oh, I see it. Right. Okay.
You need,
Yeah.
that's what's always about Latin. You need modal, break it down. Cool? All right, that's another data set. This one's a little bit old. I gotta update it. I haven't gotten around to updating it yet. This is houses for sale back in November of 2009. I was very interested in house sale prices back then, because that was right around when everything was going to hell. And I was curious to see how the market was reacting to that as far as the for sale market. There were lots of houses on the market back then, as you can see. This was just one day in November I pulled the houses off of. A word about this data set, I've truncated it visually for you. It went much further right than I've shown here. This is $0. This is $100,000, $150,000, $200,000, $250,000, and so forth and so on and so forth and so on. $800,000. This went out into the millions. There were some houses still, even in 2009, when people knew better, that thought their houses were worth 2.5 and 3 and $10 million, and they were for sale. But I call those outliers. And without getting too far into why I called those outliers, they were too, quote unquote, too far away from normal to be considered normal. Now, that's the word. Too far from usual to be considered usual. I'm going to leave that there for now. We'll come back to it, I promise. We're not leaving that go with that definition, which is all your textbook actually says about it. That's terrible. Because outliers are a humongously important part of our lives. And I want to make sure you understand them better. I devoted a whole section to it, so we'll get to that once we've got a few more tools under our belts. So, what I did though was I calculated some statistics both ways, based off this very large data set. I calculated the average, median, and mode without them, which is what you're looking at right here. And then I recalculated it with them, which is them plus the tail that you can't see. The tail did something like this. It was like ba-bum, 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 ba-bum. It's like a little stegosaurus tail sticking out with little humps on the house that were very expensive. Now check out here's without outliers, X bar. Now do you remember where we balanced the tray of cookies with the LDL? It was at the highest bar, correct? There's the highest bar now at 175. This one has to be balanced out here at 3. Why would that be?
Well, I don't know.
Yeah, because
The problem is this thing is tailing off, and every time we add a cookie over here onto this side of the tray, where does your hand have to go to balance it? It's going to have to go towards that cookie. So your finger, the average, follows the cookies when they're extreme, because it has to adjust to the extreme values. You add a cookie way the hell down there, Archimedes in the law of the lever, you have to put your finger closer, the fulcrum has to move to balance the extra weight. Or you could add more cookies to this side, but you can't. Because you can't sell a house for negative $250,000. Here, take my house, and while you're at $250,000. That doesn't happen, right? I mean, usually anyway. Shouldn't happen. It could happen, it could happen. So, the mean was $300,000 at that point, just with this data set. The median was 275, and the mode was 175. So there's your high bar, 175. 275 is this guy right here. There's your median. Median's a little bit to the right of the mode, only because you've got that tail that you're dealing with. You have to chop all that. So the chopping that we did earlier is a little bit trickier here, because it's asymmetric. So it's hard to see how many of these we have to chop before we can chop this bar off. So I would take my time with that one, or use software, which we'll definitely get to in this class too, yes. Okay, so that's without those extreme stegosaurus houses. Let's put them back in. Notice, when I put them back in, the mode, $175,000. Mode's unchanged. Why would that be?
because it's still nice frequent.
Yes, unless you're adding 120 houses that are $12 million, in which case you have other questions to ask, right, about the data set. Like, wait a minute, time out, what's going on with those houses? Unless you're doing something like that, your mode is still going to be that highest bar over here. Fair enough? I think that's fair. The median is 275. Now, that had to have moved a little bit in that bar, didn't it? It had to have moved a little bit because you added houses over there that now have to be chopped. So before we were doing that chop of the bars, we would eventually get to this bar and then we could stop chopping because we're in that bar. We would obviously be in a different place in that bar, but we're still in that bar. So the median is still 275, so that's happy. But look what changed significantly. The average is $100,000 more because remember, you're throwing cookies over there. And your finger has to go, oh crap, and it's got to move over there to catch the cookies. Or to balance the cookies. Does that make sense? Now, I'm going to introduce this now, we're going to come back to this later, is an idea of something called a trimmed mean as well. Anybody ever had a teacher throw out a lowest quiz?
Yeah.
You're right, you ever have them throw out a lowest and your highest quiz at the same time?
No.
Because statistically you should. You should statistically. You throw out the extreme high and the extreme low and re-average the middle. Technically speaking, now I'm not saying it's fair, which is why I have rainy day coupons. I mean, the whole point of them is to get rid of the low one and replace it with the high one. But what a trimmed mean does is it takes out a certain percentage off of both ends. 5% trimmed takes off the low and high 5% and then re-averages the middle. So it takes the outliers, some of the outliers off, but it will also take off some of these very inexpensive houses down here, which might be pulling the average low here. Notice how it's a little bit, it's lower than 402,000, but it's higher than the old average of 300,000. So you're basically cutting tails and reshifting the middle, where the middle is. Carolyn, go.
Is there like a certain time where you see that trimmed percentage more?
Real estate.
When there's
Real estate's a good one.
outliers
Yeah,
like that?
the great question. Is there a certain time when you'll see a trimmed mean more? Generally, I think Olympics might use it when they do certain events. Like if they have a bunch of judges.
Yeah.
It was some of those crazy arcade events with a,
That is 4.8, yes.
and what they might do is throw out the low and the high and re-average the middle 5 to get rid of any bias. I'm guessing that's probably one place where it happens. Anytime when you have a number of data points where there might be some variability at the ends, that way you get a better picture. There are other ways too, I think called a moving average. We saw that pop up on that Gallup poll. I want to come back to that too. So there are lots and lots of types of averages, and there are favored ways in certain places to use one or the other. Great question, great question. So, if you had to describe this data, would you call it symmetric?
No.
I would. Would you call it unimodal?
Yeah. Yes.
I would probably call it unimodal, yeah? But there's a great word statistically for this. It's called skewed. It's almost like you took a bell curve and then shoved it one way. You distorted it in some way to make it un-bell-shaped. So there are directions to skew left and skew right. We'll come back to that. I don't want to talk about it right now. It's not important right now. The idea, though, is that when you have skewed data, the median and the mode go, I don't care about your skew. But the average goes, holy crap! Go find the tail and head towards it. So essentially, when you have this long tail, and the tail could be on the right side or the left side, you guys, when I graph your exam grades, it's going to look like this. F to A. Because that's what happens in 243. You guys kick butt on assessments. So I expect skew from you guys. I don't expect bell curves from 243. Okay? So what happens is we can get a tail going left or a tail going right, but the average is going to head towards that tail. It's going to head in one direction. The median and the mode don't care. They're like, whatever, it's an extreme value. It's just the next biggest one. So I don't care if that one at the end is 12 million or 120 million. The median is going to chop it off first. Doesn't matter how big. But it does matter how big with the average. Of course, it has to, because the average is the equal share measure. So if a house is worth $120,000, $120 million, everybody else is going, woohoo! Because we're going to split that $120 million and we're all going to get a piece of the pie. Right? Where if you split $12 million, everybody's getting 10 times less a piece of the pie than they were with 120. Does that kind of make sense? Yeah, so the average chases the extremes. The average, this goes back to when we're Indiana State University, but let me forget that. Cool so far? So this is my recommendation. When you have skewed data, pull back from the mean a little bit. Ask yourself, should I use this, or am I going to be misleading? Actually, this is a perfect place for Indiana State University. It's a perfect place for it. So this is back in the, I think it was the mid-70s. Indiana State University reported that at the time, if you averaged the first year earnings of a graduate of their school with a bachelor's degree in business, the average earnings of a first year graduate bachelor's in business holder was $10,000 more or something per year than any other average bachelor degree earnings from any other school in the country. In other words, Indiana State University's average salary with a bachelor's degree in business was $10,000 more on average than if you took a random sample of any other school in the country, their average salaries. And they were correct in saying that. They were also hellishly misleading in saying that. Because whose first year salary did they include in that sample? And this story gets more and more convincing, or less convincing every year as I get older and older and older. Who went to Indiana State University?
Larry Bird.
Larry Bird, who then went on to play professional basketball for the Boston Celtics. So they went ahead and put his NBA salary in the computation. Were they lying?
No.
Were they a teeny bit misleading?
Yes.
Teeny bit misleading, right? So there's a great misuse of statistics. Yeah, the average was higher. It's awful. It's terrible. And they had to retract it pretty quickly. I mean, you could misuse averages all kinds with the Ford Pinto, another great example of a misuse of an average. Ford Pinto, was it Pinto?
Yeah.
Exploding gas tanks? They made a joke about this in Fight Club when Brad Pitt is sitting next to Ed Norton in the plane, talking about he works for an insurance agency, which one, a really big one, or works for a car company, which one, a really big one. He explains to them, if the probability of an exploding gas tank is rare enough and or the cost of paying the claim on the insurance is low enough, if you multiply all those things together and on average it costs less to pay the claims than fix the problem, you pay the claims. And everybody watching that movie goes, oh my God, how would you do that? Ford did it in the 70s. The Ford Pinto had an exploding gas tank problem. And they crunched the numbers actuarially, and it turned out that it was cheaper to pay off the claims of those injured than fixing the gas tank problem. Holy hell! Right? Now that would never fly in this day and age because it would be on Facebook within 5 seconds. But back in the 70s, before instant communication, you could keep that stuff buried for a while. When it surfaced, oh my God, that Shiza storm that happened. I got one last one for you. You ready for this? I'm going to describe a situation for you. This is back in the day when I taught Math 95. I gave an exam, 2 classes, 63 students. Average grade was a 71 out of 100. Out of 100. Median grade was a 78. Minimum grade, no lower than 50. Maximum, no higher than 100. What I want you guys to do is to take that data and to draw what you think the distribution of grades looked like in that class. Okay? So I'm going to have this data, I'm going to click the slide so you get a graph to look at. And I'll tell you everything you need to know. Everything you need to know is pretty much on this screen already. Let me clean it up a little bit here. Clean it up a little bit. There we go. Yep. So it's a little hard to see actually. The average, we'll come back to what that's the Greek letter mu. That stands for a population average. Don't memorize that right now, it's not important. I have that from my old spreadsheet. Average was 71. Median was 78. Can't go any lower than 50 or any higher than 100. And there should be 63 data points indicated on your histogram. As you can tell by the top of that, it's 25. There was never more than 25 students in any one of those ranges, 50 to 60, 60 to 70, 70 to 80. So basically this is F's, D's, C's, B's, and A's. Take some time right now, take a couple minutes, and draw what you think the distribution looks like. Okay?
Pull it down a little so you can see the.
I wish I could.